So in this video, we are going to go through a Boyle's law problem. It says a sample of neon occupies a volume of 461 milliliters at STP. What will be the volume of the neon when the pressure is reduced to 93.3 kilopascals? Okay, so here we have an initial volume, and then we have we're asked to find a new volume when the pressure is reduced. So I'm going to start by writing out my variables. So my V1 and my V2, it says what will be the volume. So I know that I'm looking for my V2 value. And it gives us an initial volume of 461 milliliters. So I'm going to go ahead and write that down. Then it says the sample that's at 461 milliliters is at STP. So I know that STP is 0 degrees Celsius and 1 atm of pressure. And so I'm going to go ahead and write my P1 value as that 1 atm of pressure. And then my P2 value, it says the pressure is reduced, so my second pressure is 93.3 kilopascals. So to complete this problem, I'm going to use Boyle's law, which says that P1 times V1 equals P2 times V2. But before I can substitute in for my different variables and solve, I need to make sure that I have consistent units across my two pressure values. And of course, when I solve, my units for my new volume are going to come out in the same unit I start as for my initial volume. So that's milliliters. So to me, I know that 1 atm is equal to 101 kilopascals of pressure. And those are conversions that will be provided to you on a quiz. But 1 atm equals 101 kPa. So instead of converting my kilopascals to atm, I'm just going to go ahead and convert my atms to kilopascals. So 1 atm equals 101 kPa. So when I substitute in, I'm going to have both my pressures in kilopascals. So let's go ahead and do this substitution now. P1, so 101 kPa, times V1, so 461 milliliters, equals P2, 93.3 kPa, times V2, which we don't know, so we'll plug in X. So now to solve for X, all we need to do is multiply these two values together and then divide by 93.3. So let's start with the multiplication part. Let's see, 101 times 461. That gives me 46561, and I'm going to leave off my units now that I'm doing my algebra here, and that equals 93.3x. So now to solve for x, I need to move the 93.3 to the opposite side, and I have 93.3 times x, so the opposite of multiplication is dividing. So I'm going to divide by 93.3, and I'll do that on both sides. So then I get x equals 46561 divided by 93.3. I'm going to carry this over here. X equals, I'll plug this into my calculator, 46561 divided by 93.3, and I got 499.046. But of course, I need to look at my problem to determine how many significant figures my answer has. And in my problem, I have 3 significant figures and 3 significant figures. I'm going to round my answer, my V2 value, to 3 significant figures. So 499, and my units are milliliters. And there is my final answer.